All right, guys, so let me start with a few examples on the chain rule. So we went over the definition or the theorem before, so we're just going to start computing derivatives of certain functions. So let's say y is a function of x, and let's say it's going to be given by something simple. Let's start with x squared minus 1 to the 7th, something like that. That's something similar to what we had done before. So when you take the derivative, you drop your 7, which is your exponent, copy the inside, and then multiply times the derivative of the inside. Subtract 1 from the exponent, and now multiply times the derivative of the inside. In this case, that's going to be 2x minus the derivative of 1, which is 0. So you leave it like that. So again, what you normally would want to do, or what you should be used to doing, is dropping your exponent and subtracting 1. So that you would already be doing from the power rule. However, what is different now is you don't have just x, you have an x squared minus 1. So when you have that situation, then you have to remember there's a price to pay, what I like to call there's a tax that you must pay, and that is going to be your derivative of the inside. So let's go ahead and look at another one a little bit more involved. So let's say now we're going to do 1 minus x squared minus 2 to the power of, say, 3, and then the whole thing to the power of 6, let's say. So now you have the situation where you have a function inside of your parentheses where you would take your derivative as usual, but you'll see that things will get a little bit more complicated here. And I'm going to do it in steps. So firstly, let me drop this 6, copy the inside. I don't do anything inside of the parentheses, and subtract 1 from the exponent. Okay, but now I have to multiply times the derivative of the inside. And this derivative of the inside is going to be a little bit more complicated than before, and I should have planned my space better. So I'm going to do the derivative of this. So prime there for derivative. Bad planning on my space. However, let's continue. I now need to take the derivative of this here. Let's take a look at what that derivative would look like. I want to do it here on the side. So let's take a look at the derivative of that expression. You see, when you take this derivative, you get, ooh, I cut off the 3 there. You take the derivative of the 1, which gives you a 0, and then you have the derivative of this expression here, right? So this is going to be just the derivative of negative x squared minus 2 cubed. So the way you do that is you're going to do the same thing we did before. Drop your 3 in front of the negative, or behind the negative, I suppose. Copy the inside, which is going to be x squared minus 2. Subtract 1 from the exponent. And now you pay with the derivative of the inside again. So you see you're applying chain rule 2 times. Now the key for this is to stay organized and do it in steps. Now that I got this derivative, I can plug it in here, and I get negative 3 times 6, negative 18. Copy this term, and I'm going to copy it as small as I can because the other expression is going to be large. So I'm going to write a little bit small. Now I need to multiply times these 2 other terms. And I suppose this 2x, you could multiply the 2 times the 18 and get negative 36, and then write the x at the front and make it look all organized. Now, what happened here was I had one function outside, then I had the function inside, which still necessitated another chain rule. So I had to do 2 chain rules in a row. So let's go ahead and erase this, and we'll do another example. Let's see how we do. All right, so let's take a look at an example where we have two functions composed, or three functions composed with one another. So we get multiple chain rules. So let's do something like sine of the square root of x squared plus 1, for example. So right here you have sine is is outside, the outermost function I like to call it. Then in the middle you have a square root. And then inside you have an x squared plus 1. So you're going to be doing this in steps. So let's compute this derivative. Derivative of the sine, first you just look at the outermost function. You don't care about what's happening in the inside at first, just the outermost. So derivative of the sine is cosine. You copy everything else. You don't concern yourself with it yet. Now, what you know you're going to have to pay is with the derivative of the inside. So I'm going to leave it indicated so that we can compute this separately. Why did I do that? Is because now I have a square root that is composed with I guess an x squared is composed with a square root. But you have two functions, so you're going to need yet another chain rule to compute that. So let's go ahead and copy the first term. And then we're going to compute the derivative of this. Remember, let me do it in a different color for an annotation. Remember that this right here is just going to be x squared plus 1 to the power of 1/2. You're taking the derivative of that. So I suppose my bracket should just be the term. So you're taking the derivative of that, if you will. All right, so when you're taking that derivative, you see a 1/2 is going to come down. So let's put it here. You're going to copy the inside, subtract 1 from 1/2. 1/2 minus 1 is going to be negative 1/2. And you're going to multiply times the derivative of the inside, which in this case we can compute right away because it's just going to be 2x plus 0, so just 2x. So just like that, we get that this is going to be the cosine of x squared plus 1. And now you're going to have the 2 that multiplies 1/2. Every term is being multiplied, so you can cancel. And you're going to have then here an x, and I'm going to put it in parentheses so I separate it out. So it's very clear that this is one term, this is another, and then I get this other term. One way you could reorganize this if you want is put the x and the cosine in the numerator because they have positive exponents. And this one has a negative exponent. You can put it in the denominator. Now, remember that this square root is inside the cosine, so it's being evaluated. The cosine is evaluated at that expression. So there's no canceling, but I've seen quite a few people canceling things like those. And I'm going to remind you one thing, that if you have the sine of x and you divide by x, if you cancel that, you can't, but what you get is a mathematical sin. So don't be a sinner. Don't cancel things that are inside of the trigonometric functions, because you're basically you're just evaluating the function at that value, not multiplying times the value. So some people get confused when they see things like this. They say, well, are you grabbing cosine and multiplying times? No. You're grabbing the cosine function and evaluating it at that square root. So those don't cancel, and then that remains to be our answer.